Okay, good morning, class.
Good afternoon.
Good afternoon. Good afternoon, class. So today we're looking at probability. At this point we have completed our Venn diagrams. Okay, and I've got the messages. So my one is in. Alright, so now we're looking at combined events. Okay? For those of you who want to read to this is covering on page 406. For those of you who want to watch the full lesson, it will be in the description box below. Okay, so basically what you need to know about combined events is events that's happening basically at the same time. Okay, I'm looking at example 1, and example 1 is on page. Example 1 is on page 206. 407. Okay. Example 1 is on page 407. Okay, we are told that the die is thrown and the coin is tossed. So we have two things happening at once. Okay, combined events. You must list all the possible outcomes. So if you're looking at a coin, what are the outcomes on the coin? Heads or tails? What's the outcomes on a die? 1 to 6. Not so. So if we should list the outcomes, it could be a heads 1, heads 2, heads 3, heads 4, heads 5, heads 6. Tails 1, tails 2, tails 3, tails 4, tails 5, and tails 6. Okay. So these are all my outcomes. You guys understand? Let's look at B. B says, what's the probability for a combined event of obtaining a heads and getting a prime number? A heads and a prime number. It says and. So the two events must happen at the same time. It's an intersection. Not so. So heads and a prime number, which of these 6 can be considered? Heads 2, yes? 3, 5. So the probability will simply be 3 out of 12, which is 4. You will agree with that? C. What's the probability for a combined event of obtaining a multiple of 3 and getting a tail? So multiple of 3 and getting a tail, what are my options? T3, so it's tails firstly. T3 and then 3 or T6. The probability of tails, you will normally write it out as like probability intersection, multiple of 3 or M3. Intersection tails, so what are my options? 2 out of 12, which is 1 out of 6. Right? Do you guys understand? Alright? There's more questions with regards to the sun. Huh? In the next part of the calculation, we are asked. I'm going to cut this, bring this over here. The question says, in D, what's the probability of getting a heads? So what's the probability of getting an heads? 6 out of? There's only heads. So 6 out of 12, which is half. I can write that as 0.5 or I can write it as 50%. It's the same thing. Let's look at E. What's the probability of getting a prime number? The probability of prime. So how many primes are there? H2, H3, H5, T2, T3, T5. So So it's going to give you 6 out of 12, which is also 50%. 0.5 or 1 over 2. You guys understand? If calculate the probability of you tossing a heads and the prime number. Prime number. So what's the probability of you tossing a heads? Oh. Not so. So there we got the calculation already. Probability of prime number. So which is 1 over 4. Then let's say compare with the answer in B. So what is your answer in B? B is also a quarter. And remember, this was the probability of the combined event of obtaining a heads intersection prime number. Can you see that? So just remember now, the probability of a heads intersection prime number is a quarter. And what are we given here? The product of the two, the probability of heads times the probability of a prime number is equal to a quarter. So what do you notice? They're the same. Do you all notice it's the same? Who doesn't see it to be the same? You all noticing it is the same. So something, if you're looking at tossing a coin, if you get a heads on your coin, does that in any way affect what is happening on the dice or on the die? Yes or no? No. So if you toss a heads on a coin, you can get any one of the six values on the dice. Not so. And if I toss the dice first, I throw the dice first, or the die, no? Would that number, say for argument's sake it lands on a 2, will that 2 have any effect on the outcome of tossing the coin? No. So these two events are said to be independent. Okay, you guys understand? These two events are independent. So we're going to make a little note here. For independent events. Very important to note that the probability of A intersection B is equal to the probability of A times the probability of B. Golden rule. You must know this. This question comes up over and over and over, and the learners just mess this question up all the time. If the question says the events are independent, that's the first thing you write down. Okay? For independent events, the probability of A intersection B is equal to the probability of A times the probability of B. Okay? And rest assured, if the question starts off with independent events, there will be this calculation that must take place. Okay? Then it says in G, so G says, calculate the probability of the multiple of 3 times the probability times the probability of tails. So what's the probability of multiples of 3? It's 3, 6. So it's going to be a multiple of 3 is going to be 4 out of 12 times the probability of tails. How many tails are here? 6 out of 12. Not so. So that will give you 1 out of 6. Not so. Now you compare your answer here in G with the answer in C. What do you notice? They're the same. So if the probability of tails times the probability of a multiple of 3 is equal to the probability of tails intersection multiple of 3, then these events are said to be independent. Okay, you guys understand? The events are independent. Okay, so here we can conclude. So we say since the probability of a multiple of 3's times the probability of t is equal to the probability of the multiple of 3 intersection tails, therefore events are independent. Okay, you guys understand? Okay, so we'll do example 2 tomorrow. People, enjoy the rest of your day. Good morning, class. Good afternoon, class.